So now we have Swa with Pretty Easy Privacy. Thank you.
Hi, everyone. So yeah, I'm Swa, and I want to tell you about Pretty Easy Privacy. There you find mail and Twitter and all these details. I'm reachable on IRC the best. Pretty Easy Privacy is a project that stands at the very beginning of rolling out mass encryption, like privacy for default for everyone. You might have guessed that the name comes from Pretty Good Privacy. Who knows about Pretty Good Privacy, PGP? That's just half of you. Who doesn't know? Ah, okay. So the rest was just, okay, I wondered. Who's using it? And daily? Okay, that's still a few at least, but yeah, you can see that there should be a pretty easy mode, would be much more convenient for everyone. So I can skip that one, everyone knows about PGP. In the next hour, I'll be going through these 5 chapters. I make an introduction, then I explain the technology, how PEP is built. Then I have a rather long chapter on the concept, which has 6 sub-chapters, which are rather long, some of them as well. Then really brief notes on the organization. And then, depending on the time, we can already have a Q&A session at that point, because afterwards I would be showing you some of the current apps and its implementations. And also, please interrupt me anytime if you have any questions. All right. This is Article 12 from the Universal Declaration of Human Rights. No one shall be subjected to arbitrary interference with his privacy, family, home, or correspondence, nor to attacks upon its honor and reputation. Everyone has the right to the protection of the law against such interference or attacks. And here's another quote from this guy, Edward Snowden. I don't want to live in a world where everything that I say, everything I do, everyone I talk to, every expression of creativity or love or friendship is recorded. I agree on this, but yeah, you can't control me. But the problem is we do live in such a world right now. If you look at this, the Prism, Tempora, everything we've learned through Snowden told us that, yes, they scan. Sure, not me, hopefully not you, but what with all the other people out there, all our non-geeky friends and relatives, they are more or less in this situation, most probably. So we really have a problem in this world which has mass surveillance, because online communication is visible like a postcard. So we need mass encryption to get rid of this, and then we also need mass anonymization to get rid of all the metadata. In the past, we, as Pretty Easy Privacy, have heard about many corporate environments that had tried to roll out GPG after Snowden, and then they rolled it back. So they were trying to say, okay, you can control me, but then they were like, okay, this is not really usable for our people, for our non-tech people in the company. So how we're gonna do this? One thing we did is we started an official RFC draft with the ISOC Switzerland, and somehow this talk is also like a request for comments too. So feel free to comment that at the end. I read out loud some bits of it. Building on already available security formats and message transports, Pretty Easy Privacy describes protocols to automatize operations, key management, key discovery, private key handling, that have been seen to be barriers to deployment of end-to-end secure interpersonal messaging. So what is PEP? PEP is a cross-platform abstraction to easily use existing crypto tools like GNU-PG. PEP is designed to encrypt all digital written communication with a starting point of email. We want PEP to encrypt automatically whenever and with whatever most privacy-enhancing crypto standard is available, hence the slogan, privacy by default. All end-user software must be hassle-free and zero-touch, so that it is pretty easy then. The main goal is taking away the crypto needs from the user's view. That's what we not have right now. We have it maybe with some messengers on our phones or so, but whenever it comes to crypto, okay, also HTTPS works without the user's interaction most of the time. The user has it in focus and needs to do something. So we want to take away crypto needs from the user's view. What are we not? We are not yet another crypto tool with closed user base. We are not a centralized platform provider. We're not implementing any own crypto. We're just using whatever is there already. We're not replacing any existing crypto tool per se. We are also not just an email encryption tool. That's what we are at the moment, but that's just the beginning. So we see ourselves as so-called cypherpunks, and we want to roll out mass encryption to optimize the costs of mass surveillance. We want to make the use of crypto pretty easy. The developer shall just plug it into apps, and the user shall just use it without hassle by default. And yeah, we've just started. Cypherpunks, what's this? Cypherpunks are actively engaged in making the network safer. They advocate widespread use of strong cryptography and privacy-enhancing technologies as a route to social and political change. They aim to achieve privacy and security through proactive use of cryptography. And cypherpunks write code to, not control the others and get controlled ourselves. This Cypherpunk Manifesto is quite long. I just took out some quotes. It's written in 93. Privacy is necessary for an open society in the electronic age. Privacy is not secrecy. A private matter is something one doesn't want the whole world to know, but a secret matter is something one doesn't want anybody to know. Privacy is the power to selectively reveal oneself to the world. We cannot expect governments, corporations, or other large faceless organizations to grant us privacy. We must defend our own privacy if we expect to have any. We know that someone has to write software to defend privacy, and we're going to write it. And that's also an introduction about myself. I'm by training an anthropologist as well as a carpenter, a stolar. I also studied computer science as a side course. And my name is Swa, which serves as a unique addressing in the internet and in the web. Or I'm trying to. If you want to get to know my legal name, you can check out the board members for Chaos Computer Club and Hackers Without Borders. The only female name you'd find would be mine. And I'm also involved in various hack events. See the links at the bottom. And for sure, you can't control me. All right, so now getting into the serious tech behind PEP. I'll explain you the architecture with its engine and adapters. I show you a list of repos and developing platforms and some details about these. So the general architecture is this. Oh, do we have a pointer thingy by any chance? No, okay. So on the left, you see the general architecture. On the right, there's an example. So there's an application which often is with a plugin, like Thunderbird has Enigmail as a plugin to make GPG, or this Outlook plugin comes there on top, Enigmail as a plugin. And then the app uses an adapter, which is written in the language of the app and in the functions and everything. It's like an API going down, connecting the engine. The engine is the one that actually has the API and serving the crypto functionalities, all the key management functions, and knows about the transport protocols. But I go into this in detail in each of them. So you have the engine that has all the crypto functionalities. Then you have the adapter, which is written in the language of the application so that it can just be plugged in. So the example of Outlook, you have the Outlook plugin, you have a COM server adapter to plug in the engine. Here's some more examples. For an Android app, you need the JNI adapter to plug in the engine, and for an iOS app, you would need the Objective-C adapter. These adapters are all there, but I'm showing them later. At the bottom, those URLs, you find these this graphics as well as some more information that you can also see how crazy we are and where we're coming from. The C assert and Let's Encrypt thing is still an issue in the team, so we just use both. And if you remember pep.foundation and click on PEP software, you also end up there at the end. All right, so applications, the upper level, that's the applications we already have. There's this Outlook plugin, which is already in production, already being sold, or gets sold, and is already sold. And then with an Android K9 fork, which is an email client, that's also in production, but still a beta. Then there's a Thunderbird, which uses Enigmail, which is very alpha, and PEP for iOS is even more alpha. There's more to come. As mentioned, we just started. Carmail is in the pipeline. The tech lead always wants to have MUD implemented. Then for sure browser plugins will be coming, because that's what people use out there. Then maybe your email client you can propose, and then we will also going to go for SMS and Jabber and Facebook and Twitter and whatever messengers are there, because mass encryption. So the current implementation of those apps means that it handles OpenPGP and SMIME without any hassle for the user. Again, as said, this is not about being only an email encryption client, but this is what it is at the moment, because this is what we have started with. We also need a proof of concept, and we also need something which we can write ahead cell to develop further. So this PEP versions do automatically encryption. They encrypt the subject in line. There is no key management needed anymore. There's no key server or any centralized infrastructure. Fingerprints gets translated into trust words. I'll explain this later. There's an opt-in passphrase for keys. So by default, there's no key, because remember, not anything for the user, not any hassle. And the header gets encrypted and obfuscated as much as possible. And we have a PEP sync protocol, which I'm also explaining later a bit. So that's the applications. Then we have the layer of the adapters. An adapter is a language environment specific interface between the engine API and an application development environment. This may be a language, or it could be an IDE or whatever. This is the list of adapters we already have. There's this COM server adapter for C hash, which has been used for Outlook. There's this JNI adapter for Android for Java stuff. There's JSON for all that stuff. There's Objective-C and Swift adapter, and there's a Python adapter, and there's a C++ Qt adapter. So we hope to have all the big languages and environments covered with this list, but it's not going to be the only ones. So this adapter is used in between the app and the engine, as I showed before. So the app makes calls to the adapter for the function it wants. This could be please encrypt, decrypt, please do mine encoding or decoding, please get the trust words, verify the identity, decide on a trust level for the identity and or a particular message. And then the adapter converts that into a normalized, standardized form, like standardized for the engine, for messages and makes the C library call. And then the engine magic happens, and then the adapter gives the result back to the application. The engine magic is this. The engine takes care of the messaging functions, crypto text services, the crypto API, fully automated key management services, and trust rating. It knows about all the transport protocols and the message transports. And in the future, it shall do meta protection via Gnunet. Also coming back on this later. And as a developer, you can just plug and play and you don't have to care for the crypto. That's the easy thing, is not only for the users, it shall also be for the developers. Whoever just hasn't known about Snowden but might be seeing now that Hollywood movie and is like, oh my God, my app should also do encryption, and starts using a search engine to get an idea of what this encryption thing is about. And then you might guess that after a few hours, a developer without any knowledge of cryptography would be saying, okay, nice idea, but I'd rather screw it. So ideally, they find out about us, and then they can just say, okay, great, all we need to take care is the interface between my application and the adapter, and I don't have to care about the crypto. The engine does the decryption, encryption, the MIME encoding, decoding, the message processing to the adapter, and the key management, as in generation, verification, also blacklisting, just in case someone has a broken key, and then the engine always takes out this old one, and the key synchronization of the same account between devices. So the engine drives several crypto standards on different digital channels, like different message transport protocols. It's written in C99, it's roughly 10,000 lines of code, and has those regular code audits. And no, you also can't control the engine. It's not meant to be used in application code directly. This is the list of repositories. In the middle, you see all those adapters. The rest is various things. You see the third entry is those internet drafts. That's where we drafted the RFC, which is published now. Then there's a fork of net PGP in the fifth line. And then here packages that might be interesting. That's the documentation for making packages and ready to try. That's been finished recently by a colleague, and he'd be very happy if someone starts trying it out. The developing platforms, iOS, Android, Linux, BSD, macOS, and Windows. So that's literally everything which is at least widely used. That's also making it very difficult for us because we're developing on all those platforms, we're developing in all those languages, which also means that in our dev team we have this Linux guy sitting next to the BSD guy, together with the Windows fanboy and this Google boy working on Android. So we have a cultural edge at various levels to bridge between all those people. It's kind of fun, but also sometimes very exhausting, because we're trying, to have, like, everyone who's developing on something should be really inside of this world, and that's very, very different worlds. Even though if you just look at Linux and BSD, but then the Linux and BSD guys would be getting together against the Windows, so yeah. All right, now to the concept. That's also 6 chapters. Where the last one is a rather big one, and I think I just go into it right ahead. So PEP does what the user would want to do. By teaching at all those crypto parties and writing all those how-tos into the crypto party website, we just thought, why don't we rather write all this stuff into protocols and have software actually doing it? Sure, definitely, the step-by-step guides shall not disappear. It's important to have it for all the people who really want to get engaged into the topic, who are interested. But the thing is, we want to grab all the ones that don't care with this project, because they're just out in the rain. And we can tell them 100 times, please do this, please install that, and go to a crypto party and take out 6 hours. For GPG, I usually calculated 2 hours in a crypto party. And that's when then after 2 hours, most of the people would be able to write a GPG encrypted email. But I'm telling you, in 2013, when Snowden happened, I was maybe 500 people explaining GPG, and I'm really glad if there's 5 of them still using it. So yeah, instead of writing how-to guides, we write user expectations into software and protocols to automatize all steps a user would need to carry out, taking away crypto needs from the user's view. So we started this internet draft together with the ISOC CH Swiss on the general PEP principles. It's online and ready for discussion. Very happy if you want to have a look at it. So it automatizes the key management, the key discovery, and the key sync, the private key for the private key handling. This is how it looks like such an RFC looks like, right? You've already seen the abstract. Here's the table of contents. I think I'll be going through most of it. Some already gone. Key distribution, I think I don't mention. Key distribution is handled without any central infrastructure again. So what we do and what we also write down and what we would like to see as a standard in the future is that every email has a key attached. Basta. So just every email you send out has a key attached, and that's the way keys get distributed. So it's TOFU, trust on first use, but then you have to verify the fingerprints. But I'm coming to this also later. And yeah, maybe it's important to mention that we're following the so-called opportunistic security approach, which was written in an RFC 7400 something, which basically means some protection most of the time. So it's not meant to be like 100%. You know, you're never 100% secure, but the whole opportunistic security approach is more or less, yeah, some protection most of the time. That's also what we're following. So in addition to default, we also want to make it easy by default. So easy to install, easy to understand, easy to use, no hassle, no training needed, and easy for app developers. Don't know if I need to explain on any of this. So if you install your parents when they're using Outlook, if you install them PEP, they can just continue writing emails. Nothing will change. Some colors around the application will be changing, like it will get yellow and green in particular ways. But generally, they just write emails, and you can just exchange encrypted emails with your parents without even explaining them at all. One subpart of making it easy is trust words, already mentioned before. So the idea is simple. We just use battery horse staple instead of EC5539C8FECF. So instead of reading out loud hexadecimal-based fingerprints on the phone, we just read out loud words. This, by the way, is the only piece that we cannot put into a protocol. Establishing trust can only be done by the user only. Humans can do that only. Machines cannot really create trust. You have to look into each other's eyes, or you have to listen to each other's voice to be sure whom you're talking to and to click the yes, I trust you button. But it doesn't need to be there, right? Another part of the concept is about the easy part is the sync protocol already mentioned before. It's for using the same keys on multiple devices. I'll explain it rather with those pictures. So we have a PEP user with a desktop and a phone. So the desktop is now the new device in the group. So there's a group of devices, and the new device, when it gets PEP installed, it generates a device key. That's the first step. Then it pings with this device key in the device group. And then the existing devices and the user verify the new device. That's the second picture. And then there's the handshake, and the devices agree on a secret main group key. And then all devices exchange their secret keys. And then they use their the main group key, and you can just use it on all the devices. So that also means that you can sync not only keys, but also contacts and calendar entries if you like. And then finally, this backup problem is solved too. And instead of using the cloud, which is just others, people's computers, you're using your own computers. This is how it looks in the wild. In testing, it's not out there yet, but that's, yeah, the dialogue between the computer and the phone. Then this is a really short part that's easy. End-to-end encryption, peer-to-peer transport, no centralized infrastructure or closed services. We're trying to make things right. So if you're not fulfilling any of those, or if you just miss out one, then at least at my crypto parties you wouldn't really get recommended, or only just with like a comment that, okay, if you start using it like Signal, you are part of a closed service system, which is okay, but you need to be aware about this. If it's not end-to-end encryption, you shouldn't use it at all. And if it's, yeah, not peer-to-peer transport, it always depends, but ideally you have fulfilled all of it, and we're trying to do that. As well as free software at the crypto parties also said, okay, if it's not open source, don't use it. Doesn't necessarily have to be free software, but at least open. PEP is free, and hopefully always stays free. The code belongs to the foundation. PEP has regular independent external code audits. We published one of them so far. You find it on pep.foundation in the blog, I think, and also in /docs. You find the actual document. And there's another quote from the Cypherpunk Manifesto. We publish our code so that our fellow cypherpunks may practice and play with it. Our code is free for all to use worldwide. That's how it should be. Then the compatibility, already mentioned a bit. Again, we don't want to create yet another crypto app. We don't want to implement own or new crypto. We don't want to replace anything, but we want to be compatible with everything which is out there already. So we want to be compatible with multiple crypto technologies, multiple message transports, platforms, and languages. This is the crypto. We already support the bolded stuff. The rest is coming sometimes. There's a net PGP missing, which is for iOS now used. This is the transport protocols, which we already support, all the email protocols like Exchange and SMTP, IMAP, POP3. Then next on the row is XMPP, which is the protocol of Jabber. And then we also want to support all the non-open standards like Twitter, direct messages, Facebook, messaging, Google, whatever is there, what the people use. But then also go into freaky stuff like Gnunet, and also encrypt SMS. Like, not an issue. If you have an SMS application, you can plug in the PEP engine right here and right now. Okay, the documentation is a bit bad, but like, talk to us. And then you can encrypt your SMS with GPG. Last part, anonymity. Content encryption is not everything. We all know that for email, metadata stays visible. So the from, the to, the IPs, where you're sending from, where it gets received, the subject of the email, the size, all this is all still visible. It's just the main body that is encrypted. So what PEP does, it already encrypts the subject in line. You can opt out on that, but it works pretty well. It's just the first line of the body, just says subject, colon, and then this is the subject. And all the clients who are already PEP compatible, they interpret that right and put this line, which comes after subject, colon into the actual subject field, which is very convenient because now we all have those weird encrypted subjects in our inboxes and we're searching for an email and we have no clue where to find it. And then it will obfuscate and encrypt the rest of the header as much as possible. But that's only small things. This thing is a bit bigger. Gnunet. To explain Gnunet, I usually use this analogy of the Internet 1.0, which was in the 70s and the 80s, where everyone was like, oh, wow, I can access your computer and you can check out mine. How awesome is that, right? This is how it was in the 80s. We were all like, oh my God, this is now a network and I can access remote computers. This is amazing. So now 30, 40 years later, we're like, yeah, sure. What's the point? We can access other computers and we can use their services. But then wait, what? They can also access mine. This is how I started the crypto parties, with the sentence of, if you are connected to the internet is also connected to you. So this is the state where we are at the moment. And where we're trying to get to is the Internet 2.0, where we have end-to-end encryption and anonymization of the way data flows. This is this Gnunet. You broke the internet, let's make a GNU one, is the tagline, and sure, it's about this thing. Gnunet is a mesh routing layer for end-to-end encrypted networking and a framework for distributed applications designed to replace the old insecure internet protocol stack. It's been founded in the 2000s. 2002 was the first white paper published. It's been followed up on universities. There's lots of master theses and PhDs and whatnot. There's been various research groups, but it's quite a big task they're trying to do. So to explain where they're standing right now, I use this layer analogy of the internet. You might know about the OSI-ISO model. So this is a very hard, simplified version of the internet now. We have the physical layer, we have an Ethernet layer, we have the IP PGP layer, we have the TCP UDP layer, we have the DNS X509 layer, and then we have the Google and Facebook and Co. layer, which is the reality at the moment. People are just using the web, right? So now Gnunet on the other side, I'm also putting a very hard, simplified version of Gnunet, for sure. So starting with the physical layer here at the bottom. Here we need to start with what we have to hide the presence in the network. So we do communication over many transports such as TCP, UDP, SMTP, HTTP, HTTPS, Wi-Fi, and Bluetooth. On this layer, Gnunet has unreliable, out-of-order packet delivery semantics to obfuscate as much as possible. And then there is this ATS, the automated transport selection, that decides which connection to establish and selects the best transport plugin to use. You might know this from very restricted networks where you suddenly change your SSH port to 80 because in a hotel you can only use web, or in a train because people don't even think that there would be more in the internet than web. And then you put all the services you need on port 80. You might have done this before, and this is also something like that. So this ATS just decides which connection is the best to use. All right, the next is the so-called core, where Gnunet runs effectively an off-the-record link encryption between peers. It multiplexes inbound messages by type to higher-level subsystems, and it hides connections from two peers that do not speak the same higher-level protocol. This is like the Ethernet layer for Gnunet. The next one is about decentralized routing. Distributed hash tables, DHT, are used. It's basically a routing algorithm that is decentralized. Gnunet includes a distributed hash table, which is a randomized variant of the CADIM linear that can still efficiently route in small world networks because, yeah, it'll start small. Here we come to the heart of the project, Cadet, the transport protocol. It's similar to SCTP, the stream control transmission protocol, and serves end-to-end encryption. On top of Cadet, additional services are created that provide more application-specific functions. So for example, for PEP, we are building something called Xolotl, not Axolotl, but Xolotl, to protect metadata, and Lake, to provide replicated anonymous encrypted mailboxes hosted within the overlay network. Those mailboxes are then used for asynchronous delivery. I guess you haven't heard about Xolotl, yes, without the A, which is a mix of Sphinx and Axolotl. Axolotl is that signal protocol. One of the Gnunet devs just said recently, it's like Mix Minion on steroids. And then those guys conceptualized something called Lake that's coming out of the idea of Pond. You might have heard about Pond, but it's coming without any central services. And now if you're like, okay, what? The important part of this is by all science and mathematics we know today and all the results we got by the Snowden revelations and their reactions, all the metadata will be gone that way. That's the important part. So this is the, Cadet is the heart, that's the replacement of TCP IP. And it will be then there without any metadata. The next part is easy. That's the GNS, the GNU name system, a secure and decentralized naming system. Unlike DNS, GNS does not rely on any central root zones or authorities. It also provides an alternative public key infrastructure, and it's interoperable with DNS, and also very important, it achieves query and response privacy. That's the basic thing in all those protocols of Gnunet. And now finally introducing, ta-da, the applications. Not too much yet, but at least there is an application called Conversation, which is a secure decentralized voice over IP. Then there is SecuShare, which is a social networking application. Then there is GNU-Taler, which I just gave a lightning talk about as well. That's privacy-preserving payments. It's like online cash. There is anonymous and non-anonymous file sharing. There is an IPv6 to IPv4 translator in a tunnel. And then in generally, yes, we need you and your creativity and maybe your coding skills. But generally, we're far away from, like, don't expect now you install it and then you have those applications and you can use them. This is like far away. The applications exist, Gnunet exists. I come to it later, how to install it. But it's, yeah, it'll take some more years till actually get this productive. But the mass surveillance is also now there for many, many years. And I'm personally, I mean, I've worked so much on the symptoms of all this, like creating crypto and teaching people and everything, and I'm just sick of it. I don't want to fight against the symptoms anymore. We really need to get to the root. And I believe there is no other way out. We just need to create a new internet, which is by design serving what we need. This is a image. I've zoomed into here a bit more. You find it on youbroketheinternet.org, which is a group around Gnunet. So they also tried to split the internet up into those various layers and put in what is already existing and gave, like, the green stuff is good, the red stuff is bad, and everything else is somewhere in between. And so if you're interested and you don't want to read and all those papers and that stuff, then this might also be interesting. Generally, the goals of Gnunet is to become a widely used, reliable, open, non-discriminating, egalitarian, unfettered, and censorship-resistant system of free information exchange. It also wants to serve as a development platform for the next generation of decentralized internet protocols. So yes, development platform. As already mentioned, it's not ready for use that much, but you can already start being a node in the network, so you can clone that repository. Please do not use the release, because the release is from 2014, and that's quite unstable meanwhile, or it is stable, but it's kind of unusable. But just use the current Git version. All the release stopping candidates are already closed, and we hope that there will be another release, hopefully within this year. So you can clone that repository, you can follow the instructions on the website from that release, which at some parts might not help you, but then you can get support in the #Gnunet on Freenode or on one of those various mailing lists. The help isn't too active, but there's a developer one as well. And then go ahead and report the bugs on gnunet.org/bugs. This thing is mostly written in C, but there's also Gnunet Java. So the idea is to have an API for extensions in Java to be able to have this on Android. So if you're into that, that will be very helpful if someone can have a closer look at it, because till we're ready with Gnunet, people won't be using any computers anymore. They will be just using their smartphones. So to summarize the concept up, users don't have to think about the crypto anymore. They can just use it by default. A journalist wrote once this at the bottom. It is this little hacker inside that decides on the cryptography chosen to communicate with the message recipient. This is what we do nowadays all the time. Like, you talk in an IRC channel, and then you start a private chat with a person, and then you're like, oh, you cannot do OTR in IRC. That's not so good, so let's change to somewhere else. What do you have? Do you have Jabber? And then we can put OTR on there. Okay, yes, great, let's move over there. And then you're like, oh, but I'm about to leave the house. Can you do Omemo and Jabber? Because OTR will fail once I left the house. And then you're like, okay, oh no, you don't have Omemo, so we can move over to Telegram. So this is what we do every day. I at least do that, I guess. Some of you at least as well. And this is what we do just naturally, because we're like living in that scene. But we cannot expect this from all the people out there. Like, definitely not. And we should also stop trying to expect it from them and trying to missionize them and tell them, oh no, don't use WhatsApp, this is evil and blah, blah, blah. Let them just do it. And what we're trying to do with this is we just sneak it under. Like, we just sneak it into their systems, and then it's just there by default, and then nothing changes for the users out there. So then they have all this little hacker inside that decides on the cryptography chosen to communicate with the message recipient. All right, then brief notes on the organization. We have a company, or actually two, and a foundation. The company sells applications and services. One is for business to business, one is business to customer, but that's still on idle because, there aren't too much products yet. Then there's a foundation, which is founded to support free software, and is especially there that the code belongs to the foundation, because whenever something with a company happens, that can happen anytime. Look at the OwnCloud Nextcloud story. Then we can just say, okay, company gone, we just restart, because the code always belongs to the foundation, and you'll see that, right? Also, some notes on the financing. The company sells applications and services, which hopefully in the future will really create a revenue. At the moment, it's mainly money from the founders, friends and family, and the users, like the usual investor, FUBAR, and also there's a support from the government of Luxembourg, the usual IT, startup support, blah, which they have. And the foundation has donors, as any foundation has. you can see the founding documents on PEP Foundation/docs, where you can read all the amounts and who has given how much and all this. Generally, the company and the foundation are Luxembourg and Swiss based. This often sounds a bit fishy when you just see it on the website and you're like, okay, Swiss and Luxembourg. But that's because the people founded this is people from Switzerland and one guy from Luxembourg. So that's how it is. We cannot, we're from Switzerland, we're from Luxembourg, what shall we do? So it looks fishy, but it's also, we're anyway crazy, so maybe it's not too much of an issue. Okay, 45 minutes gone. I would say if there's any questions on this part, I'm happy to take them, and then we can take the rest of the time to have a deeper look into the apps. Yeah, this one. I forgot.
Yeah, I have one question about concrete implementation of the PEP. I mean, is this like you're injecting this part of the code into the executable, or is it by using some plugin system or something like that?
There are no monitor boxes, so speakers. I cannot really listen what you say. Maybe you repeat?
Yeah, I was asking about how do you implement PEP? How do you include privacy into the Outlook? I mean, are you patching the executable or some? Yeah.
You just install a plugin. So we wrote a plugin in this C# language or whatever they use, and then you can see it as a patch by option, but I think the concept in Outlook is called add-on.
Yeah,
but it's the usual plugin, add-on, add-in concept where you just install it in addition, and then you have this patch.
Yeah, I'm asking because some of the tools you mentioned doesn't have like a plugin architecture. Yeah.
Okay. So with K9 we created a fork. So we just took it. It's open source and just made another branch of it. For iOS, we're creating a full new MUA, like a new mail client. And Thunderbird is having this Enigmail plugin where the Enigmail developer Patrick Brunswick is directly working on it to implement it because he's also glad for the approach. And I think in general, either the application people do it themselves, that's what we aim for. But then if we have something where we really want to add something into, then if it's open source, we can create a fork, we can create a plugin, add-on, whatever it's called, and that would be the various ways.
Okay, thank you.
Okay, can you hear me okay right there? Do you see any potential for implementation difficulties between users who are more sophisticated, who prefer doing their own key management entirely on their own, and who have been using all of these tools for years in various different formats, and then users who I think are your target audience who don't want to have to manage keys and things like that? Do you sense any implementation problems involved in the politics with that, because the people who've been using these tools for a while, it's like, oh, you have to manage your own keys and verify your own blah, 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 and then I just want to talk to you and not have you listen.
Yeah, so you definitely have a very important point here. So lots of people wouldn't be happy about this opportunistic approach anyhow. I remember this when I've done the crypto parties, then people were like, oh, how dare you just install the people's software and they don't even know what they're doing, and oh my God. So during the crypto parties, I solved that problem with a disclaimer at various points where I just say, okay, this is like, if it's serious for you, if you're a lawyer, if you're a journalist, something, then this is just like a quick walk through the options you can start going through. But if you just want to have like a little more privacy, then it's nice you have an umbrella against the rain of mass surveillance. You would still be getting wet. but at least you're standing not in the rain without anything, and you can even maybe drag some people along. But then with PEP, we definitely have this problem. So for example, the opt-in passphrase. Oh my God, how can you have a GPG key without any passphrase? I remember when I imported one of my keys to my Android phone myself, and I still haven't done it with my main keys, just with my PEP keys, because it felt so weird to have a GPG key without any passphrase. So that's like crazy. But that's what we're like, the sophisticated users, they can still use their old solutions. Also the Thunderbird Enigmail, which most of us most probably use, you can still then change into the advanced mode. So you have PEP as the default mode, it comes with a wizard and the usual thing, and then you can switch to the advanced mode, which is then the old mode. So for the experts, everything stays the same. The only thing they need to change, but that's already happening anyway, independently from PEP, that the public key needs to be attached by default by any email. So when a PEP user communicates with a non-PEP user, the non-PEP user, which is a GPG user, needs to, with the first handshake, attach the key, like by clicking attach my key or by doing in whatever way. The email client does this normally. But this is definitely a discussion we have to face all the time. Because for the sophisticated user on the one hand side, as well as for the highly targeted user, PEP is not really a solution. This is just the umbrella against mass surveillance. Because with the opportunistic approach, that also means, some encryption at most of the time, and the combined with the easy, no hassle approach, that means that if something fails, an email will be sent out unencrypted. That's one of the design principles of the PEP standard is no hassle for the user, and if like sending out or being able to communicate stands above everything. So the first prio has the actual communication. And then second prio is that it is actually encrypted and whatnot. But that again, you can do then in the settings that you can say, okay, if stuff fails, then please do not send out encrypted. But that's again like the passphrase. By default, you don't have any passphrase because by default, the user, like your parents, you're installing the Outlook plugin, they don't even know that there's a key. They don't even know that there would be a passphrase on that key. They don't know all of this because the key just gets generated by installing, and then it just gets attached with the first email, and then the reply is already encrypted, right? So you install it to your parents, and then they send you a first email, and then you send it back with a key attached as well, and then you already have your encrypted channel established, and there's nothing which they know about. So that's a discussion we have to face, and that's where we need to go. But I'm still, I remember, and it must have been really long time back because it was still on ICQ, that my sister was chatting with me, and suddenly the OTR session started, and I'm like, oh. And she's like, oh, what happened now? And I said, oh, just click OK, that's fine, and whatever it says, just click yes, yes, please go away. And then I asked her, are you on the Mac computer of your friend? And she's like, yes, how do you know? I'm like, okay, because Adium already back in, it must be more than 5 years back, had this OTR by default, like OTR messaging for instant messaging, had it by default installed. It was not a plugin or something you had to activate. It was just there. So as I also was using OTR on my client where I was using ICQ, our clients directly handled the key exchange. And then my sister just got this pop-up, oh, do you want to verify your partner of what it says? And then I just told her, yeah, just click OK, it's fine. I'll explain you once we meet. And I was really sitting there with, oh my God, now I'm chatting encrypted with my sister. Online, like, and she's not a geek at all, and that was amazing because she didn't know. She didn't know anything. She was just like, yeah, okay, I do what you say, because she trusts me, right? And this is where I would like to see email as well. And then, sure, if it fails in between, then it fails. This is not a full protection you have. You will never have a full protection. But you're definitely better protected than with some of those serious apps then. Yeah. Is that replying to your question? Yeah, okay. Any more question?
Hi, more technical question about the key synchronization between devices. You said you can do it between devices, so can a user then use the same keys, transfer them to their phone? Yeah, that's the idea. So they'll be using the one key on all the devices.
Yeah, so every device has an own device key.
Yes.
But they're all together using this group key, which is then your key. Like if someone sends you an email, it uses that group key. And then the group key distributes it on those devices. So there is definitely, like, every device would be having an own key. But the communication partner just uses one key.
Okay. So that also solves then the problem of losing keys, actually. Because you can lose one device and still have the same key.
Yes.
Okay.
So that's why I said there as well, the backup problem is solved. Unless you lose all your devices at the same point, but then you anyway have another problem. And that's, I was commenting this with them, you don't have to store your backup in the cloud anymore, which is others people's computers, but you use your own computers. So ideally you even have, like if you're, like I'm traveling a lot and I have all my devices with me, so if I get robbed, they would be all gone. So I think in such a situation, I would just take any old crappy phone, install it, and have it syncing regularly, and just plug it in my mom's place and tell her to check sometimes if it has internet. And then if I get robbed, that I'd still have one device which still owes my keys.
Thanks.
Thanks, great. 1, 2. Thanks, great talk. Maybe a follow-up to the earlier question. How do you handle rekeying and key revocation? Like, do you envision a UI for that? Partially because, like, if I lose a device, I may want to revoke my old key and transition to a new key, which can be daunting even for advanced users of PGP.
Yeah, that's a very good question, and I'm not totally sure how it works in detail, but it kind of works the other way around. So you then say to the device group, okay, this device is now not verified anymore, right? You like kick it out, and then they again make new keys and a new group key. And then the distribution means that, so now your group key is a new one. So now every email you send will have a different key attached, which means that the another PEP user would be then getting, when you send an email, it would be getting the red flag, oh my God, the key has changed. And then you again need to call each other to verify your trust words. And a non-PEP user, you have to actually notify somehow. And I think something like a broadcasting or so might be then even a method that you just say, okay, like everyone I've been talking to the last 3 weeks or whatever time range you choose with GPG now just gets a message of, okay, I have a new key, because you don't have the key servers anymore, so you cannot make a reload. But that's anyway a problem nowadays as well. Like, at least I barely refresh the key list, and then it happens that you send someone and then they reply, oh, sorry, I've lost this key and all this. Yeah.
This one's, I guess, a little bit more out of field. How would you respond to people who say, oh, well, as long as we get all of the mail operators or server people to just implement TLS and DANE, that takes care of 98% of the problem of transit and things like that, and then we're fine. How do you answer that criticism? And I hope I'm setting you up for an awesome answer.
You see that bottom line here? Sure. That's definitely a thing. So when I said that email is like everything is visible, only the thing will be encrypted, that's basically not really true, because ever since Gmail was enforcing TLS enforcing as in it was only accepting TLS emails, it changed very heavily. Nearly every email provider would be having TLS nowadays, which means that on the way everything is encrypted already, but then you have to trust your service provider. So you always have to trust someone. You have to trust your service provider, as in your email provider. Sorry about that. Not your internet service provider anymore. You don't have to trust those guys, but you have to trust your email provider, which you can do by your free will and choice. But generally, this is not end-to-end encryption. So it is encryption in the way the data flows through the network. That's true. But it's not end-to-end encryption because the mail server would be still knowing about this. We also have the option, by the way, to trust your mail provider or not trust your mail provider, which means that emails get stored encrypted or unencrypted. So then that has to do still with the thing that you cannot search encrypted emails at ease. So it's easier to actually have them stored. So if you're having your own mail server, for example, or of your friend, and you really trust that person, then you can say, okay, please store all the emails unencrypted so that I can search them at ease, and that whatever I can do exports and backups and whatnot. Or you say, no, please store them only encrypted, because I like the moment I get it on IMAP, I have it in my client, it gets unencrypted anyway. So when I'm using it, I can use it, and whenever I'm offline, it's encrypted.
Maybe a follow-up, or certainly you talked mostly about confidentiality. Another advantage you may get is authenticity. Authenticity, you know who wrote that email. Instead of, to follow on Nick's question, even if the communication to the email server is encrypted, I still don't know who sent that email. And now if it is signed, I actually know, hey, this has been written by one of my friends, or somebody who has access to the device of my friend.
Yeah, true. Thanks for that comment. Okay, now it's been 1 hour. I would say I still scroll very briefly through the screenshots I brought along, and then we can. It's not even. Oh no, it's been exactly 1 hour now with the delay. The delayed started, and then I can take some more questions, or we just go. But we are not having any talk right ahead afterwards, no? Okay. Or is there any urgent question right now? No. Okay. So that's the current implementation. I've already shown this before. So this is the K9 fork, which is ready for use. You can download it in Play Store or F-Droid. Yeah, that's also a small detail on the culture we're coming from. Most probably it will be costing money on Play Store at one point, and it will always be free on F-Droid. So, yeah. This Outlook plugin ready to use. You can contact us for a testing license if you're interested, because it costs money. You can buy it in the shop. And then this Enigmail plugin for Thunderbird coming with the next release. The old mode still stays available. This is a screenshot from a testing environment. And now into the actual demo use case. So this is the picture especially I wanted to show. So it starts at the upper left. So 2 users installing PEP. Whereas the one user doesn't have to be a PEP user, but it's easier now if we have 2 PEP users. So the other user just needs to be a GPG user that knows how to attach a key. So now Bob sends a message to Alice, the first one, which is unencrypted, so that one is gray, and has the key already attached. So in the moment of installing, the key is generated. So now the email gets sent, the key is attached. Now the first email gets back, and now this is the yellow mode, which means this is already encrypted, but not verified. This is like when you start an OTR session, you're just like, yeah, fingerprints, and let's go on, right? Then you're in the yellow mode. So in the yellow mode now you can stay forever if you like, but by these ample semantics of yellow and green, and also there's a red mode, we want to somehow bring the user to this only interaction they have to do, which I mentioned before. This is the only thing we cannot put into software, is that they call each other and read out loud those trust words. And then the applications make those handshakes, and then you're in the green mode, which is the verified and secure mode. So you're encrypted and verified now. This is another diagram on this. So you have the first interaction in one direction, unencrypted with the key attached. Then the direction back, key attached, already encrypted. Now you make the verification on a phone line or whatever you choose. And then you're in this secure and trusted mode. So this is then how it looks in Android, installing, adding the server details. And then now here you have the first email, which is gray, and the second email that's yellow. And then you can click here on the upper PEP to handshake. And then you have your trust words. Maybe your communication partner doesn't use the same language as you do, so you change the language to any other one. So now we're in Spanish. But maybe your communication partner doesn't use PEP at all, so you need to have the PGP fingerprints, so you can go through them. But we're thinking of having somewhat of a bot or so that the PGP user who's already experienced can translate its PGP key to fingerprints, its fingerprints to trust words, sorry, so that the non-experienced user doesn't even get to know about these things. Yeah, so you click yes, I trust, and now you're in the green mode, and you can send out emails, and then you can also disable protection as well on demand and be in the gray mode again. That's for Outlook. You need more or less recent Windows for this. Then you install, and we're very proud of this. Someone made a brief comparison of installations, so we're faster and less clicks than every other solution out there. So this is the weird Windows stuff you have to do, installing, installed. This is happening if you have already a GPG4Win instance installed, so it asks you to overwrite or to install somewhere else. So this might be confusing, but whoever has a GPG4Win already installed might be knowing what this means. Then you also have this silent unattended installation for corporate environments where you can just run in a console with admin rights. This Kung Fu, I don't know, magic Windows. And now we're in Outlook. So now you have the, on the bottom left, the unsecure mode, the gray mode, then the yellow mode. You make the handshakes, and you're in the green mode, and you can also reconfirm the trust words, and then you can also disable the protection again. Then you're again in the unsecure mode, and you can still attach your key, and yeah, this was it. Thank you. Nice. Okay, any more questions? Or I also brought some stickers. I actually forgot them, but thanks to Busche, I have them now. Oh no, that's the wrong ones. They're inside there as well. Great. So I have this friend who has a sticker company who also makes all those stickers for Congress all the time. You might have seen them. You don't see my laptop now, but he also made us a bunch of PEP stickers. So I leave them here now, and I take them to the front desk then as well. So it's the PEP logo and the privacy by default and these things. Yeah, any more questions? I'm around anyway the rest of the day and tomorrow, and yeah, thanks for listening.